Formula 1 has always been and will always be the pinnacle of motorsport, with its worldwide popularity and incredible technical performance. Formula 1 car is able to accelerate from 0 to 100 in 2.5 seconds and reach a maximum speed of more than 350 kph, extracting the maximum out of the hybrid power unit with only 1.6-liter V6, which has a phenomenal efficiency of more than 50%. As well as a gearbox that can shift in 5 milliseconds and extremely efficient brakes, all while having a huge amount of downforce, which slows the car down a lot in a straight, but allows it to corner at incredible speeds, creating a 6G load on the driver, which is more than an astronaut taking off on a rocket. And all this with open wheels and under extremely strict regulations, making all these figures together an incredible achievement by the engineers. But despite that, Formula 1 cars are not going to get any faster. At least not for the foreseeable future, rather they are going to slow down considerably. And the previous generation of cars, which existed from 2016 to 2021, deservedly called aerodynamic monsters, will go down in history as the fastest on the lap. But why is it so, and why are the new generations getting slower than their predecessors? Let's find out in this video, and also discuss in detail the worries of new regulations for 2026, in particular what's wrong with the new engine, which will no longer produce 1000 horsepower because of the new hybrid. If the maximum speed or acceleration in Formula 1 is not too impressive, but the lap times are still unmatchable for other cars, and the decisive factor is downforce, created by all aerodynamic elements, which pushes the car towards the road, allowing you to carry more speed in the corners and brake more effectively, thereby gaining lap time. But when downforce is created, turbulent flows are also formed, dirty air that remains behind the car, and deprives the pursuers of downforce, not allowing them to take turns as quickly as the car in front, turning racing into boring driving at a distance from each other, without fighting. And Formula 1 has been trying to solve this problem for many years with the help of technical regulations, to reduce the amount of dirty air created by cars. But the 2017 cars, unlike other regulations, were designed to solve a completely different problem, which led to a serious mistake by the championship management. For many years in a row, Formula 1 has simplified its aerodynamic regulations, reducing downforce and dirty air, which led to general dissatisfaction with the performance of the cars from 2014 to 2016. Alonso spoke about this especially clearly. The budgets and capabilities of the teams allow us to make fantastic cars, but now, even though we are sitting in a car with open wheels, they are too slow, and the amount of grip feels like in a GT car. Therefore, Formula 1 decided in the new regulations to make the cars much faster, by accelerating them up to 5 or 6 seconds per lap, by increasing downforce and returning refueling. To add downforce, they increased the airfoils under the motor bigger, wider, faster. The width of the car increased from 1.8 meters to 2 meters. The front tires became 6 cm wider and the rear tires 8 cm. To create even more grip, the front wing increased by 15 cm. The side deflectors were lengthened by more than 2 times. The rear wing has been increased by 20 cm in width, but with a lower profile and sloping backwards, along with the return of shark fins. The rear diffuser has been increased in width and height by 5 cm and by 7 in length, which altogether gave a huge increase in downforce on both the front and rear axles, allowing for much faster lap times. On average, the cars got faster by 4.2 seconds, and this is considering that it was decided to abandon the return refueling, and the minimum weight increased to 722 kilograms. However, this increase in downforce has led to an equal increase in turbulent air behind the cars, which is created by all sorts of new aerodynamic elements that create downforce and push the air to the side to isolate the aerodynamic elements of the car from the turbulent air coming from the wheels, which became the main problem and a huge mistake. Overtaking has become even more difficult, since it's simply impossible to follow the person in front in turns. If you are one car length away from the leader, then you lose about 50% of your downforce, which is good on a straight line. But before each straight, there is a turn, in which you just can't carry the same speed as the leader. In addition to this, you get less clean air to the wheels, and they begin to overheat, wearing out even more, with which therefore Pirelli is not doing well. As a result, these regulations further aggravated the dominance of one team and the lack of fight on the track. But the lap times were truly amazing, beating the times of both the previous regulations and the cars of the legendary 2004. This was only the first year of regulations, and from there the teams continued to gain momentum, even though the FIA slowed them down slightly in 2018 by banning fins and aiding halo, which increased the weight by 10 kilograms. In 2018, the federation tried to simplify aerodynamics, to reduce the volume of dirty air and simplify its development, allowing smaller teams to get closer to the leaders. The front wing was increased by another 20 cm, while simplifying and reducing the number of wing elements. They also did the same with the rear wing, making it 10 cm wider, but again simplifying the end plates, which created a lot of turbulent flows. And the power of DRS increased by 40%. The badgeboards have become 10 cm longer, but 15 lower. These were all small changes in the hope of making these regulations easier to live with. After all, it was assumed that everything will change in 2021, with the arrival of ground effect, and 2020 will be the last for these aerodynamic monsters. It was in 2020 that this generation of cars reached its peak. It was then that almost all the records of the current F1 tracks were set. Just look at these lap times and compare them to the current ones. The difference on some tracks is simply terrifying, but as we know, due to the COVID, the 2020 season turned out to be short, and it was decided to move the new regulations from 21 to 22. However, in 21 there were still some changes that were designed to slow down the leader, that was Mercedes, and slightly reduce downforce. A piece of the rear edge of the floor was cut off. The diffuser elements and winglets of the rear brake air ducts have also been reduced, significantly reducing the pressure on the rear axle. At the same time, the minimum weight has increased to 752 kilograms. All these changes slowed down the cars in corners and made the 2022 cars the fastest in history. And the 2021 season became one of the most interesting because the regulations allowed Red Bull to catch up with Mercedes. As we have already said, the main problem of that generation was inability to chase the car in front, and the drivers, in order not to lose too much time and not to overheat the tires, had to keep a distance of more than 3 seconds between each other, and the effect of the dirty air was significant even with a 6-second gap. That means that the dirty air from the leader, who was braking in the first turn of Bahrain, impacted his pursuer, who was just crossing the start and finish line. Now I imagine how much of an impact this had in turns. And although these were indeed incredible cars on one lap, as the drivers themselves say, it was difficult to watch them in races. Which is what the same drivers constantly complained about, talking about dirty air and overheating of the tires, hoping for improvements in the new regulations. The 2022 cars were supposed to solve the problem of chasing and fighting on the track, improving the quality of racing, while not being too far behind their predecessors on the lap, and over the course of the year they could even catch up with them in pace and be fast on certain tracks. As a result, the average gap from its predecessors turned out to be more than 1.5 seconds, and from the fastest cars in history, it was as much as 2.8 seconds. Even on tracks with high-speed corners, where the ground effect was supposed to be more useful, the new cars were slower, falling behind the list on tracks with long straights. The 2020 cars were still raw, so I suggest look at the comparative telemetry of the 2023 and 2020 cars. In 2023, DRS has become more powerful, which we see in the example of how the 2022 cars perform at the end of the straights, whereas the 2023 cars has a maximum speed of 10 or 15 kph more. You may get the impression that the acceleration dynamics have become better, but this is simply due to the different engines. If we compare Mercedes with Mercedes, we see that there is nothing like that. And so the drivers really began to pay even more attention to corner exits. The new cars are worse in everything. They just don't have enough downforce. They carry less speed in each corner. Here it's 18 kph less, there it's 14, here it's 16, and so on, almost in every corner. Which also leads to loss of time during braking. We have a high maximum speed at the end of the straights, and at the same time, due to a lack of downforce, we need to brake to a lower speed than before, which in addition to the increased weight, affects the braking distance even more. But very rarely, new cars can be on par with the old ones, in sequence of medium speed corners, such as the Ascari in Monza. But at the same time, even the 2004 pole position on this track was faster than what we have now. But don't think that it's all just a matter of aerodynamics, because the cars began to weigh 792 kilograms, and 10% of ethanol was added to the fuel, which reduced engine by 20 horsepower. However, the first goal of the rules was fulfilled, and the quality of racing really improved. In the first half of 2022, we had an interesting fight for the championship, as well as a fight on the track. The number of overtakes in the season increased from 599 to 785, and the drivers themselves noticed that it has become easier to chase rivals in corners, being able to stay less than a second away from them, and at the same time not to overheat their tires. The next year, other teams also caught up with the regulations. If you put aside the dominance of one driver, there were fights for second and third places at the finish line of the season. This was also noticeable on the track because the number of overtakes increased to 1083. 4 different teams fought for the second place in the Constructors' Championship. And for the first time in the history of Formula 1, 5 different constructors had at least 8 podiums in a season. And Perez showed us that if Max wasn't so fast, then this whole group of drivers could have fought for victories all season. What can be called the success of these regulations. But not everything is so simple. We will return to this later. New aerodynamics help to reduce the amount of dirty air. Formula 1 in these regulations has reduced the load of the wings and reduced the various deflectors that created most of the turbulent air. Now the cars have become more cleaner, generating downforce mainly with the underfloor, and then directing the flows from under it upward using a diffuser, the lower rear wing, and the main rear wing, so the dirty air goes up, hitting the pursuers to a lesser extent. Thus, the main dirty flow went upward, and the pursuer received only what was left of other elements and wheels, losing only 15% on downforce, being 1 car length behind from the leader, while in 2021, in the same situation, he would lose 50% of it. But already in 2023, the trend changed, and teams were able to speed up, despite the fact that due to the porpoising, they had to raise the car and make the suspension stiffer. In addition to working with the floor and suspension, interesting solutions began to appear on the verge of legality. In particular on the wing, slots and aerodynamic elements at the attachment points, which again began to create vortices, diverting flows away from the car in order to better isolate the floor, creating that virtual skirt that was in the previous regulations and greatly affected the cars behind. As a result of this, the Purser began to lose not 15% of downforce, but 35%. And in 2024, we have a Mercedes wing that tries to recreate the Y250 vortex of previous generations, which created a lot of dirty air. So you definitely shouldn't expect that the Federation will decide to somehow speed up the car in the near future, but we should expect on the contrary a continuation of the slowdown on the lap due to a decrease in downforce, and not only. About which we already have information regarding changes in 2016, which we will now analyze. In the next generation of cars, the management decided to go even further. The cars will no longer push air to the side or isolate the car from the dirty airflows emanating from the wheels, but will, on the contrary, direct the air towards their own car. This is the main change in the concept. So for example, the side deflectors, instead of pushing the turbulent flow from the front wheels to the side, will redirect it to the underfloor, like a plow, under the leading edge of the floor and further into the Venturi tunnels, the entrance to which can now be located higher, which will allow more air to be driven under the floor, and the second fin, located further, will divide the flow in two, and again direct it to the floor, and not to the side as before, to isolate the edge of the floor. The same is expected under the car. These changes will seriously reduce downforce by removing that same virtual skirt that ran along the car and hit the driver behind. Now the air will be directed to the car, mostly under the floor, in order to then direct these flows together with the main one upward, due to the rear wings, as in the current regulations, and affect the pursuers even less. The front wheel deflectors will increase in size for better control of dirty flows, and the new wing with the end plates indented from the edge will help direct flows to the wheel both from the outside and from the inside, normalizing the turbulent flow emanating from the lower part of the wheels, which should help a cleaner flow to get under the floor, instead of diverting this air to the side. In addition to this, the car will become narrow by 10 cm, and the wheelbase will be shorter by 20. This will significantly reduce the aerodynamic surfaces and lower the level of downforce, slowing them down in the corners even more. But at the same time, the weight will decrease by about 30 kg, which is approximately equal to an acceleration of 1 second on the lap. The wheels may also become lighter and smaller, moving to 16 inches, and reducing the contact patch, which will further reduce the grip. On the positive side, the front and rear wings look interesting, both of which will receive a DRS system, which can significantly speed up the car on the straights, reducing drag even more effectively. But the front wing itself should begin to produce much less downforce, since the wing flaps have become much narrower, and a bigger part of the wing will be responsible for normalizing the turbulent air coming from the front wheels, which can lead to a lack of downforce on the front axle. These changes will seriously slow down the car, according to some fears, even by 4 seconds, and I assume even more. In which case, the Japanese Super Formula will soon be able to impose a fight on a Formula 1, which, by the way, also has a rather interesting design. And that is the trend. But the fewer dirty airflows there are behind the car, the more fight we will see on the track, and reducing the size of the car will add nimbleness, which its bodies have been lacking for many years. We shouldn't forget about the changes in the power unit. The overall power will not change, but the ratio of this internal combustion engine and the hybrid component will change drastically. The hybrid will account for half the power, which should also reduce weight by eliminating the MGUH thermal energy recovery system and reducing the fuel tank. This is where the good ends, because it's not clear how much 1000 horsepower, where the distribution between the internal combustion engine and the electric motor is 54 to 46%, will be weaker than the current version, where the ICE is responsible for 83%. If now we have 83% of the power, that is approximately 830 horsepower all the time, and 17% that is 160 horsepower, depends on the battery charge. Then from 2026 we will always have only 54%, that is 560 horsepower. and the remaining 470 will depend on the battery. Overall, the reasonableness of the new hybrid part remains a mystery, since the battery volume remains unchanged and will be the same as now, 4 megajoules. Max Verstappen, for example, is worried that at the end of long straights they may need to downshift as the battery runs out. Judging by the simulator, if you drive on the Monza straight with full throttle, then 500 meters before the turn you will have to downshift to save charge, which just looks terrible. But other than that, Formula 1 still has a few years left, and Monza is the worst track for this hybrid. But at the moment I think it looks really bad, based on all the numbers and what I'm seeing from the data so far. So at the moment I'm not happy with the new regulations. And since Max is talking about this, then these fears are indeed real. Now the electric motor can be used to its maximum and produce 160 horsepower for 33.3 seconds, without the need for charging. There are simply no tracks in Formula 1 where you need to go full throttle for 33 seconds without brake. There will always be a corner where the battery can be charged using kinetic energy. However, the new electric motor from the same 4 megajoule battery will produce a maximum of 470 horsepower only for 11.4 seconds in a row. And in the same Monza that Max spoke about, he put the pedal to the floor about 15 seconds on the main straight, which confirms Max's words. Just about 4 seconds before the end of the straight you will have to downshift if you use the electric motor at the maximum power. And this is Monza. If you look at the Baku, you will find out that on the main straight the driver goes for 25 seconds full throttle, and we also have Las Vegas, where it's 20, and so on. Long straights for F1 are not that big rarity. To drive the straight in Baku with full throttle, you will have to use a maximum of 215 horsepower of electric motor, and that gives us not 1000 horsepower, but about 750 on average, depending on what point the team decides to use more or less power, conditionally more during acceleration and less at the end of the straight, which no longer sounds so impressive and optimistic. That is what happens when marketers start creating regulations instead of engineers. The only good thing I can say is that not all tracks consist of long straights, and Baku too, so somewhere, for example in Monaco, there will actually be more power, but the main thing is that the straights need to last no more than 11 seconds, otherwise we will see a huge drop in performance of maximum speed and lap time. Perhaps it might be a very powerful overtaking button. It's also unknown where the MGA-K kinetic recovery system will be enough to charge the battery in a timely manner, since MGA-H will be removed, which by the way is responsible for 52% of engine efficiency and solves the problem of turbo lag. But at the same time, everyone's favorite sound of engines might return, and MGA-K will remain as before only on the rear wheels. But the regulations will now allow the battery to be charged at 9 megajoules per lap, although its maximum charge is 4. That is, the battery will be constantly charged and discharged throughout the lap as it is now, which it seems to me, unlike eco-fuels, makes this experience not very applicable to conventional electric cars, where the battery is used according to a completely different principle. Adrian Newey puts it this way: the other problem is the battery. What we need, or what the F1 regulations need out of the batteries, in terms of power density and energy density, is quite different to what a normal road car needs. And that in itself means that the battery chemistry and possibly battery construction is different, so there's a risk that it won't be directly road relevant. Also, the new engine will not have variable geometry intake system. Don't forget about fuel. If adding 10% of ethanol in 2022 resulted in a loss of 20 horsepower, it's hard to predict what will happen in 2026, when the formula plans to switch to 100% eco-fuel, and 20% of ethanol will have to be added, which will probably further aggravate the situation with engine power. You also need to understand that for the last 2 seasons, the number of Formula 1 viewers had been falling after the peak of 21, and despite the fact that regulations brought the teams closer in the fight for the second place, where 4 teams fought for it last year, the general viewer is still more interested in the fight for the first place, even if only 2 drivers fight for it, and then there is an abyss after them. At least that's what the statistics say. Limitations on team budgets and time in the wind tunnel are already having an effect. Let's see if Red Bull, at the end of these regulations, will receive something similar to what Mercedes received in 2021. But as you can understand from this video, the Formula 1 management is not going to make cars any faster, but teams will continue to try to make the most of the existing rules. Ross Brown's ideas about active aerodynamics can help solve the shortage of engine power, who proposed in future regulations to make 2 operating modes of the car, configured for downforce for cornering and for a minimal drag on straight lines, so that this would be activated not only in the DRS zones, but on an ongoing basis on every lap. While all the regulations may be postponed, and the battery may also be increased. For me it makes no difference where a car completes a lap at 1:30 or 1:33, but when the cars can't chase each other and when they can, it's a very big difference. And as the same Bottas and many other drivers said, if the new cars allow us to fight more on the track, then it will be more fun than driving incredible laps in qualifying. Here I think everyone will judge for themselves what is better for them, as well as in choosing between the fight for first place with 599 overtakes in the season, or the constant fight for second and third places between different teams and 1083 overtakes. Write in the comments what you all think about this. If you liked the video, I remind you to like and subscribe, so as not to miss new videos. And pardon my accent and wording, I've been having no English practice for years, but will try to do better in the next one, if you are interested in these videos.